Hi everybody, this video is going to cover section 9.3, which is proofs with parallel lines. You might want to take a minute and pause it and write this down because I'm going to hopefully talk pretty quickly and we'll be referring to this. So first of all, we've talked about these before. We have been studying corresponding alternate interior, alternate exterior, and same side interior, and we're going to continue talking about them. So just to remind you, corresponding angles are angles that are in the same spot, like the upper right-hand corner and the upper right-hand corner. So we could say angle 2 is congruent to angle 6, for instance. Now there are others, but those would be some of them that we could talk about. Then if we talk about alternate interior angles, then we go to the interior and we go to different sides of the transversal. So 3 and 5, for instance, would be alternate interior angles, would be congruent. And the next one, alternate exterior, well, we'd have to go to the outside. So that maybe could be angle 2 and angle 8, because those are on different sides of the transversal, but they are both outside. So that's angle 2 and angle 8. And finally, same side interior, that would be like angle 3 and angle 6. And same side interior, those are the ones that are going to be supplementary. All of the other ones are congruent, but same side interior are supplementary. Congruent, 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 supplementary. So we've been talking about this for a long time. This is not new to us, but we are going to continue to use it in this next couple of units. So the next part that we want to talk about is up here we had 3 lines, a parallel set and then this transversal. But we also have some information when we just have 2 lines. So this is 3 lines, this is 2 lines. We would have vertical angles and congruent. Vertical angles are the ones that are across from each other. So maybe angle 11 and angle 10. And those are congruent, so I should have put a congruent sign in there. And then supplementary is a linear pair. Those are the ones right next to each other. So that'd be like angle 9 plus angle 11 equals 180. Or you could also say angle 9 plus angle 10, because those make a linear pair as well. I went ahead and changed my sign to a congruent sign here. Okay, so all of that is review. We've been working with that for some time, and now we're going to talk about how do we put those in proofs. Well, remember that proofs are little if-then statements. And up here, I don't know if you noticed, but I stated this in terms of an if-then statement. So if there are parallel lines cut by a transversal, then all these things can happen. If 2 lines intersect each other, then these things can happen. And so we're going to take that information and change it into a proof format where we have little if-then statements. So here we have this diagram. If M and N, here's M and N, are cut by transversal T, then angle 3 and angle 6 are alternate interior. And that is the definition of alternate interior angles. And we can abbreviate. If M is parallel to N, then angle 1 is congruent to angle 8. If we look at angle 1 and 8, those are alternate exterior angles. Two and 7. 2 and 7 are alternate exterior also. If M and N are cut by T, then 6 and 4 are same side interior, and that would be the same side interior postulate or definition. And angle 1 and angle 5, those are corresponding. And angle 4 and angle 8, those are also corresponding. Oh, sorry, we have corresponding. We should call this one definition of corresponding angles. And maybe we should do that up here as well. Let's add the word definition of alternate interior angles, because they're just saying that that's what they are. So that's just a definition. When we say that they're congruent, then that might be our theorem. And so we can write the word theorem, or I'm just abbreviating by THM. This one would be a definition because it didn't say anything about the size of it. It just said that's what they are. But then again, this one would be a theorem. So those are some theorems that we have talked about that deal with angles. So on the next page, we're going to talk about how to put those together. All right, remember I was just saying a second ago that this should really be like an if-then statement. And so we also know from our previous experience that what we do is we put the given in our first line, and we say the reason for that is given. And we also know that we put the last one is that angle 1 is congruent to angle 11. But we've talked about that's not proof, that's not a reason. We have to work through the reason. Okay, let me tell you about how these are going to work. What we're going to do is we're going to like move around the square, like pretend like this is a square, like we're going to play like the alligator game when you're a kid where you can't go inside of it, okay? We have to go around the outside of it. So let's think of if then. If L is parallel to M, and I'm going to highlight these so we can see what's going on. So we're just talking about L and M. And we need to somehow prove that angle 1 is congruent to angle 11. And that one's all the way over here. Okay, well, one thing I know, kind of an easy one to me, is that if I have parallel lines, which I do here, then corresponding angles are congruent. So again, I'm going to work my way around the square. I'm kind of trying to jump all the way around to get to the 11. Okay, so I can say that angle 1 and angle 3 are corresponding angles, and we can also say that those are congruent. Okay, so I'm working my way around the square. I've started off with 1, and I'm going to move over here to 3. I want to try to get down to 11. Well, a couple things. Notice I only used one of my givens. My given was L is congruent to M. Let's use the other given next. Let's say parallel, not congruent. P is parallel to T. That also is a given. I need to back up a second. I forgot a reason. Why is angle 1 congruent to angle 3? Well, because they're corresponding angles. And quite honestly, you all, some of these are postulates and some are from theorems, and I'm not real picky on whether you call it a postulate or a theorem. I'm pretty sure this one's a postulate, but don't worry about that. But that's what I'm saying. Corresponding angle postulate says that those two are congruent because they're corresponding angles, and we know that if they're parallel, then they are congruent. Okay, next step. P is parallel to T. All right, I'm going to ignore now. I'm going to erase all my highlighting. Okay, so now I want to focus my attention on P and T. And again, I'm trying to work my way around. I'm trying to get to angle 11. So I went from 1 to 3. I said that those were corresponding. I need to somehow get to this next angle 11. Well, that's actually pretty easy because it's corresponding as well. So I can also say that angle 3 is congruent to angle 11. And the reason is the corresponding angle postulate. Okay, now we've run out of lines, and so we need to be ready to now say that angle 1 is congruent to angle 11, which we can. If we look back at what we've written, we have angle 1 congruent to angle 3, angle 3 congruent to angle 11, and now I'm saying angle 1 is congruent to angle 11. I took these two and I basically put them together and I came up with this. Do you remember what that's called? I call it like when you cut out the middleman, like we're going to cut out the middleman of that angle 3. That's called the transitive property. So the transitive property allows us to jump and skip that middleman and just say angle 1 is congruent to angle 11. Okay, let me tell you, this pattern that we've just done is going to occur a lot, and we're going to kind of almost memorize this pattern. It's going to go if then, and if then, and transitive. That's going to be our pattern. Given, reason, transitive. And the way we're going to do it is we're going to walk around the square and play the alligator game so that we can't go inside there. So we're just going to walk around and get there until we get to our angle. Okay, let's try another one. Okay, I'm going to utilize that pattern I was just talking about. If then, we can have our given statements and then we're going to end with this. And the pattern is usually going to end in transitive property, so that's probably what's going to go down here, but it might not. So actually, I'm going to write it because I think it is, but we might have to erase that. What I do know is I have to do a given and then an angle, a given and then an angle. And the angles I'm trying to get to is from 2 to 15. So I'm trying to get here from angle 2 all the way over to angle 15. I don't want to go in the middle. I have to play the alligator game and get on the outside. So I can start off by saying angle 2 is congruent. All right, let me look for something over here. What would it be congruent to? How about angle 4? That is a corresponding angle. So angle 2 is congruent to angle 4. That can work. Now I want to jump, so I went over here. Now I want to jump from there all the way over to 15. Those are related. Do you know what angle 4 and angle 15 are called? Those are called alternate exterior angles. So alternate exterior angles are congruent, so that gives me that statement there. Okay, let's check and see if my transitive is right or not. So I said originally 2 is congruent to 4, and then 4 is congruent to 15. I cut out the middleman, and I say 2 is congruent to 15. That's the transitive property.